Hey there, beautiful people. So this Google slide has a periodic table, and what I want to do in this activity is just give you some general notes about the different families on the periodic table, just so that you can have something formal to put into your notebook and refer back to later. So what we're going to do is we're going to color this periodic table and fill in all the information related to the different families. Now, families are generally groups of elements, meaning up and down, the columns on the periodic table. And so different families have different properties. So let's go through some of them and color them in. The first one we're going to talk about is this section here from lithium to francium. So lithium, sodium, potassium, rubidium, cesium, and francium. Here's how you're going to color this in on your end of the periodic table. You're going to come up to the shape section here. You're going to click on shape. You're going to pick a rectangle right here. And you're going to draw yourself a little rectangle that covers all of this first column's elements. Now, obviously, that's not helpful because now we can't read any of the elements that are underneath. So what we need to do is change the color. So we're going to come up to the paint bucket for the fill color. We're going to click fill color. Then we're going to come down, and you'll notice that there's this plus sign that's under the custom section. Click the plus sign, and now you can pick whatever color you want. So this first one, I'm going to pick like a really dark red. Now, what I want to do is I want to change its transparency so that I can see the colors that are underneath. So I'm going to click on this bar here, drag it over to about 1/3 right there, and click OK. Now you can see that I have darkened that particular section of the periodic table, and this section is what is called our alkali metals. Now, so let's label that right now. Come up to your toolbar right above hydrogen. You'll see the line, and we're going to just choose arrow. And we're going to draw a nice arrow here. And it's a little thin for my liking, so I'm going to make it thicker by clicking on this line weight and doing 3 point. If you like it thin, no worries. You want it thicker than that? Go at it. Okay, so now that I've got this arrow, let's identify what it is by putting in a text box. So these metals are called the alkali metals. Now, what's special about the alkali metals is that they all have only one electron in their outermost energy levels, and we'll get into that when we talk about the atom. And they're super, super, super reactive. You'll notice that many of these are used in different salts. So like lithium chloride, sodium chloride, potassium permanganate are all different types of salts. So they're ionic compounds, so they like to form ions. And we'll talk about this a lot more when we get into the next section on the atom. But all of these are super highly reactive, do not appear in nature by themselves. They always are reacted with something else, because if I were to take something like potassium, pure potassium, which is a soft gray metal, and leave it out on the lab bench, it will just explode by touching the air, the water that's in the air. So now let's go to this next section. This next section, we're going to do the exact same thing as we did before, which is just going to change the color. This next section are elements that we typically define as minerals or nutrients. So these are what are called our alkaline earth metals. I'm going to make them yellowish. Make the gold. Okay, transparency. So they're typically things that we associate with nutrients or minerals. So we know that we need magnesium, strontium, and calcium in our bodies for good, strong bones and healthy skin. Beryllium, magnesium, and strontium are typically found in different types of minerals. And they are the things that add color. So beryllium is responsible for making rubies red. So different types of combinations of these are going to give you different colors when it comes to different types of gems. And these are what are called the alkaline earth metals. So one of the things that my students usually find from year to year to help them remember this, in case they forget, alkali has one word, alkaline earth has two words, column 1 versus column 2. Okay, now let's transition. So these are all super reactive metals. Like I said, the alkali metals are so reactive they'll explode if they touch any type of moisture. The second elements are not found in nature by themselves either. They're always found in some other compound. Even the calcium that we drink when we drink dairy products does not come from pure calcium. It comes from something else that our body pulls the calcium out of. Now, as we move to the right on the periodic table, we encounter this big section that's right in the center. So let's change the color on this one. Let's make this some version of blue. Here we go. We'll make our transparency about 1/3. So this big section has a lot of the things that we would consider traditional metals: copper, iron, silver, gold, platinum, zinc, those chromium are all metals that if someone said to you, picture a metal in your head, you'd probably picture one of those. These metals can be found in nature sometimes, and sometimes they're only found in other things, or sometimes it's both. For example, like iron can be found in rust. And these are called the transition metals. And they're called the transition metals because they transition us from the highly reactive metals on the left side of the periodic table to the less reactive metals on the right side of the periodic table, like lead and tin, which don't really react with many things. So these are called our transition metals. Now there's two more families that we want to talk about. Let's go to column number 17 over here, family 7. Is actually a little bit odd because we're only going to do the top 4 elements. Okay, so it's not the whole column here, it's just the top 4 elements. Let's make this some sort of green color, because chlorine. So what's really funny about these elements is that these top 4 elements all have something in common. So whereas the first column only has 1 electron in its outermost shell, these have 7 electrons in their outermost shell. But what's interesting is even though they have that, that's very little, that's really the only thing they have in common. Fluorine is a yellow gas. Chlorine is a green gas at room temperature. Bromine is actually a reddish-brown liquid at room temperature, but if you hold it in your hand, it'll immediately evaporate and turn into a brownish-orange gas. And iodine is super cool. It's a purpley silver solid, but if you rub your hands together and make your hands warm and then hold on to the iodine, it'll actually it'll sublimate. It'll go directly from solid to gas without passing through the liquid phase. So, and turns into a purple gas. It's actually super pretty, but super deadly. So now let's identify this group as our halogens. Okay, so these are our halogens that are those 4, and it's only those 4 are those halogens. And then lastly, let's jump into our last column, and we all know this last column. It's the one we always remember from middle school. These are our noble gases. I want to try and make this as hot pink as I can so it matches closer to what is in my classroom. So these are our noble gases. They are very non-reactive gases, non-metals on this side of the periodic table. I did my arrow wrong. Let me spin that arrow in the other direction. There we go. So these are our noble gases. What's special about the noble gases is, besides the fact that they're all gas, is that they're all non-reactive. Or fairly non-reactive. They have a filled section of their electron structure, and because of that, they don't have any room to make bonds to anything else. So those are all noble gases, and even OG, the old OG down here, oganesson, which is brand new, is also a gas, is also a full outer shell. Okay, the last thing I would like you to do, and this one's a little bit tougher, is we're going to draw a black line. So we're actually going to make a series of black lines, and we're going to make them slightly thicker, so like 3. And we're going to, we're going to make those black lines go like this down our periodic table. And all I'm doing is copying and pasting this to darken this section in. So this is what is called the staircase. And I'm going to make some horizontal lines in here too. Oops. And then we're going to connect the dots from one to the other. If I can draw a straight line. By the way, if you want to draw a straight line, just hold down Shift and click across, and it'll always be straight. Okay, I'm going to make this 3 point, I'm going to copy and paste this. Give me a second. And it's not going to look perfect, and it's not going to necessarily look pretty, and that is perfectly okay. It just has to be there. Oh, we're going to stop right there. Okay, this is the staircase. So you can now see this darkened line. So this is the separation between the metals, which are everything on the left, and the non-metals, which are anything on the right. There are metalloids along this staircase, and the only exceptions to them are aluminum, which is a metal, and acetine, which is a non-metal. But boron, silicon, germanium, arsenic, antimony, tellurium, polonium have properties of both metals and non-metals. So here's what we're going to do. We're going to add a little text box up at the top, and we're going to make a note for ourselves. We're going to go metals, left of staircase, non-metals, right of staircase, and metalloids along staircase. Okay, and then the only other thing we're going to do is we're going to make this just a slightly different color. So we're going to change our fill so that it stands out. That was silly. I put gray on gray. Let's choose some sort of red. And then lastly is I want to add one more text box because students always forget this, and I'm going to make this yellow so that it's really bright and in my face. Okay, so on the periodic table, when I say the word period, what I'm saying is rows. So if I said to you someone's in period 5, I'm referring to row 5. So RB, strontium, all the way across. If I say group, then I'm referring to columns. So if I say to you group 17, you go to the 17th column, and you know I'm talking about anything that's in the halogens or astatine and TS. So put that on the top as well. I don't know why that happened. And those are your notes for the periodic table. That is everything you need to know right now. I'm going to give you a little bit of assessment on this next class, just asking you to use this in application to answering some questions. If you have any questions, as always, feel free to reach out to me, and I am happy to help.